So it's interesting, reflecting on the last panel, on the actual, not just the plans, but the actual construction in China, you know, it struck me how beautifully simple the idea is. You know, move water where it is to where it's not. Move south water north. So they've got the South-North project, and I guess we could, you know, call Nawapa the North-South project. It's just, it is that simple, that kind of elegant as a concept, and I think it's worth starting there from just the subjective impression that anybody, any sane person will feel upon, you know, thinking about this project. That's kind of the pathway to the objective, some of the objective truth about it, which we've been discussing and we'll get to more today. It is kind of a proof of the equivalence between beauty and truth that, you know, many poets and others have often spoken of. This strikes you as beautiful, as an idea. And I do want to maybe just indicate where the truths in that lie as far as a science that Mr. LaRouche has developed, uniquely, although on the shoulders of others, you know, which he's coined the term physical economy. And in fact, in large measure, our approach to this project, at least in taking it up again, and not simply taking it off the shelf, you know, where it's gotten dusty, but really reconceptualizing this project and representing it both in a new political context, but also in all of all the scientific implications, the cultural implications, those aspects which are actually going to be the driving force to realizing the project itself. Because clearly, while the idea may not have died, having a good idea for a good project clearly isn't enough. Otherwise, it would have been done 47 years ago. Now, it is a useful starting point that we've got a design for something which is a guaranteed increase in physical profit for the United States. A guaranteed increase basically in every category that you could imagine. Both because of the more obvious aspects of taking what's essentially a huge unlivable portions of the country, or marginally livable portions of the country, and transforming them with the thing that they need most, namely water and power. It's in the title, or in the name. But also in all of the associated aspects, and people who have seen the videos on the website will have a good sense of the kind of manifold character of the logistical framework required for this, the fact that it will involve a reindustrialization of the country, the fact that it will bring huge amounts of hydropower, but is also the vehicle through which you'll have a nuclear renaissance in the country. These are as much part of Nawapa as the 160 million acre-feet of water that are going to be coming down from Alaska and Canada. On its own, it's not enough. And nobody here is making that claim that this will solve certainly not all the world's problems, and definitely not all, not to speak of well, it's not all of the United States' problems, not to speak of the whole world. It is a seed crystal. It's the necessary seed crystal for an explosion of growth around the planet. And so much of what we've discussed as Nawapa involves, by implication, Nawapa and its global extensions. Most immediately, both north through the Bering Strait into Russia, and as that interfaces and connects with Central Asian development, water projects there, and the development projects in East Asia and in China, as Dr. Chang reviewed, and also southward into Mexico, through the Darien Gap into South America, and really being the keystone for the Eurasian Land Bridge project, which has been a mission of this organization to realize since the early 90s, when it was proposed by Lyndon and Helga LaRouche. So it's a keystone, it's a science driver for the development of the globe. And it's it embodies that necessary character of planetary development. The idea that we really are in a phase, it is true, we're in a different place in history than we were 47 years ago, in the sense that more and more physical economy, especially the approach to things like resource development, whether it be water, whether it be mineral resources, that has to more and more take on the character of a planetary problem. You know, rainfall doesn't really care about national boundaries. It's not really partial to any one country or the other. Just as none of these other deposits, which have been laying over millions or billions of years, were particularly cared about where they ended up. And so the idea of, and that's a good thing. If every country had everything it needed and had no necessity to talk to other countries, that also, as Cody was sort of indicating, would be a weird universe. So it will require a new level of cooperation, of international cooperation, and that's a good thing. It's also something which is, maybe predestined is too strong a word, but it is a natural outgrowth of a kind of a geological imperative on the planet, this kind of cooperation. It's not a purely political question in that sense. It really is a physical question which is as closely tied to the development of the planet, as I'll maybe indicate in a second here, as is the development of all the natural environment. That is, this falls under the category of what a Russian scientist by the name of Vladimir Vernadsky termed a new phase in the development of the biosphere, which he called the noosphere. Let me actually read a quote from Vernadsky's paper. It was actually a paper written very close to the end of his life. And it's in funny circumstances. It was during World War II. So the irony of this is you've got the entire world engulfed in this conflagration of global warfare, which is obviously that was a terrible tragedy. Vernadsky was a diehard optimist. And so even through that, even recognizing the horror of that war, he recognized that the significance, were we to come through that, and he was confident that we would make it through, that the human civilization would make it through, it already indicated a certain kind of planetary significance of the human species in maybe a more striking and immediate way, and a somewhat terrible way. But on the flip side, that geological phenomenon that Vernadsky recognized that was taking shape, accelerating in the 20th century through the development of industry, of electricity, of the communication, instant communication across the planet, and the spread of human beings across the entire planet. It indicated to him a scientific truth. And let me read a quote here. He says, "The geological evolutionary process shows the biological unity and equality of all men. Homo sapiens and his ancestors, Sinanthropus and others. Their progeny in the mixed white, red, yellow, and black races evolves ceaselessly in innumerable generations. This is a law of nature. All the races are able to interbreed and produce fertile offspring. In a war of such magnitude as the present one, he finally wins who follows that law. One cannot oppose with impunity the principle of the unity of all men as a law of nature. I use here the phrase law of nature as this term is used more and more in the physical and chemical sciences, in the sense of an empirical generalization established with precision. Mankind, taken as a whole, is becoming a mighty geological force. There arises the problem, of the reconstruction of the biosphere in the interests of freely thinking humanity as a single totality. This new state of the biosphere, which we approach without our noticing, is the noosphere. So that's not just a descriptive term. It really represents a qualitative feature of the universe, more immediately of our planet and our entire species. So it's a useful, it's a necessary conception in thinking through how to place, how to conceptualize the kind of process which NWAPA and other projects represent. That if we take a look back, and we have material on the website that elaborates some of this, so I will try to be brief. But we have a certain tools, and we've developed a certain idea, developed a certain understanding of planetary geological processes, the biosphere as a whole, and not in small measure helped by the fact that we have a space program. That's another, I think, useful irony to recognize. It was when we left the planet, when we began to actually have remote sensing, manned spaceflight, and so forth, that we really were capable of understanding what was happening on the planet at a far deeper level than would ever be possible. Modern agriculture today is as dependent on satellites and the space program as rocket development. But we've developed a certain view. So if we were to shrink that narrative down to about 5 minutes here, and it's then we could say a couple of things. We could say that by the time man appeared on the planet, say, well, be broad, within the last few million years, maybe longer, give or take, the history of the planet up to that point had developed to a certain degree where life had colonized the entire surface of the planet, had reached pretty much as far as it was going to go upwards. We've got birds, far better adapted to flight than their predecessors. You've got microbes and other things floating around in the atmosphere. There's a certain upper limit to that. There are also surprising violations of that. We've found actually little critters floating up where the space station hangs out, and one of these little critters, the water bear, is able to go into a dormant stage and survive in the vacuum of space, the radiation environment, and so forth. So there's still, I think, surprises to be had in determining the actual limits or the extent of the biosphere, but pretty much it had gone about as far up as it was going to go. It had gone down, or maybe perhaps came up from the deep. We know that only in recent decades we've discovered a huge, deep biosphere, which by some estimates could be as massive as the surface biosphere. We're very prejudiced, us surface-dwelling creatures, But there's a whole population of microbes which have been very active over geological history down in the depths. Probably more active than we realize. Responsible for all kinds of things. Could play a huge role, in fact, in things like petroleum deposits and other things. The oceans, likewise, fairly well colonized. There's still lots of room out there. But we've got critters in the deep, around deep sea vents, where the tectonic forces are pushing the continental plates apart. Normally wouldn't think is very habitable. Tons of life there. It's a great place to live if that's your thing. There were important innovations along the way. Probably photosynthesis is one of the most important as far as biotechnology is concerned. In some ways, trying to reach beyond the confines of the planet itself. As far as we can gather, the earliest life had to use the energy sources available in the immediate environment. whether it came from the depths, whether it came in the primordial soup or wherever. You had certain chemicals that they fed on, and that was pretty limited. That's unsustainable. And so photosynthesis allowed these plants in a certain way to stretch themselves off the planet and begin using an extraterrestrial energy source from the sun. Made that, incorporated that into the active growth of the biosphere. This obviously made the colonization of land possible by plants and other critters, in turn bringing a more active hydrological cycle onto the land, increasing the moisture content, the recycling of certain elements. And this, of course, bringing the hydrological cycle on land involves a bunch of other so-called cycles, biogeochemical cycles. Some of them have gotten a lot of attention, like the carbon cycle, of the flow of carbon dioxide from the atmosphere into plants, into the soils, back into the streams, back into the atmosphere, and so forth. Life played a crucial role in that. The nitrogen cycle, we've got most of our atmosphere is composed of nitrogen, but for the most part it just sits there. Now, it takes bacteria and other living processes to turn that into a form that's usable for these plants to munch on. And this then gets percolated through the soil and washes out to the sea, eventually makes it back out. Mineral formation, again, got to give a lot of credit to the deep biosphere for that, but also surface processes that get recycled down into the ground. And again, another area where we're finding out that life has had much more of an influence on the concentration, the creation of certain minerals and ore deposits that we now find not just useful, but necessary for our survival. So expanding the initial array of mineral elements that came, in the box, so to speak, to thousands, multiplied it manyfold. So that thumbnail sketch, the history of the Earth in 3.5 minutes, but that thumbnail sketch gives you a sense of the kind of process, a beginning from which, into which mankind appears. And this obviously operated over a long period of time. At any one given time, life appears to be a relatively weak force. It's a very small percentage of the mass of the planet, very small percentage of the mass of the biosphere, if you just count things that are actually living organisms. But over geological time, this had become the most dominant geological force on the planet. Which poses the question, that the principle of life is something that has always been here. And what we're really seeing over this process of development is its manifestation through certain periods of crisis, and then growth and development, differentiation, more activity, more power. And also involving, as Cody alluded to, again, extraterrestrial help, we'll say, cooperation from the galaxy. Galactic cycles, again, we'll just indicate it here. There's more material on the website, but the very close connection between galactic cycles and the correlation between that and cosmic rays, galactic cosmic rays, correlation between solar radiation and evolutionary processes on Earth. But that's pretty much the extent of life's extraterrestrial imperative. The development of a vast array of senses, of sensory apparatus to be able to see in spectrum, in parts of the electromagnetic spectrum that we find, that we have no direct access to, or at least that we're not conscious of. So it's been quite innovative and ingenious in making use of its environment. But again, that's the limit. Life, you're never going to see a dolphin get together with his buddies, figure out how they're going to build a rocket and take dolphinhood off the planet. In that sense, the biosphere had reached a limit. So now we look at the action of humanity over comparatively very brief time period. Now you've got an acceleration of all of that. You look at the water cycle on land, the irrigation, I mean, that goes back thousands of years, connected to the agricultural revolution. At this point, there are whole regions where we've, at least at a regional scale, increased, by a significant amount, the moisture in the atmosphere, and so forth. So things associated with the water cycle, again, the things that's associated with. One of my favorite examples is nitrogen. There was a certain period of time where the most valuable pile of bird guano was off the coast of Peru and Chile, where farmers who wanted to fertilize their crops had to go, make a pilgrimage to this huge pile of bird droppings, which was rich in usable nitrogen, which was a limiting factor for a lot of plant growth, and especially agriculture. And so, about 1914, people figured out how to take this vast reservoir of nitrogen that we have in the atmosphere, almost unlimited, and do what the bacteria up to then they had cornered the market on. And we busted in, and at this point we're producing, the estimates are, as much or more nitrogen for industrial processes, mostly for fertilizer and feedstock, than is being produced by all of the nitrogen-fixing bacteria on the planet. And so that's a very clear case of taking over and dominating one of these biogenic cycles, and others, and on, including more exotic cases of not just refining minerals, not just introducing native iron and aluminum and so forth, and concentrating them, but introducing new compounds, alloys, and new elements altogether. If you look at a periodic table of the elements, that's only a small part of the story. You look at a table of isotopes, of all of the different kinds of manifestation of these elements. You've got thousands, and most of those are man-made. So this kind of process now of again, what might at any one time seem a relatively weak force, but over the course of now, not geological history, but human history, much more compacted time scale, appears as the most powerful geological force on the planet and potentially in the solar system. And this kind of general idea, with obvious, more to be filled in, but this sort of context frames all of the cycles of production and consumption in human economy. It's sort of a backdrop for that. And what LaRouche once called the first law of physical economy, the necessity to overcome depletion in any existing resource or resource base, was to a certain degree accomplished by the biosphere. It reached periods of crisis, it reached periods of limitation, and had to grow and develop new forms of life, new forms of physical processes to deal with that. The difference is now with the human species, with, in a sense, that entire process now concentrated potentially in an individual human mind. That this now takes on a new qualitative form of consciousness in not just accelerating this process of development, but bringing it to new levels of organization. Now, what's different about it? We're not merely consuming stuff. Even the few examples mentioned, you take agriculture, irrigation and agriculture. What's that connected to? It's the development of astronavigation, the understanding of astronomical cycles, spherics, dependent on a fundamental discovery of principle. What about fertilizers? What about Metals, metallurgy. Well, fire, first of all, but fire and its cousins, or its offspring. You know, the use of biomass, the use of burning wood, discovery of coal, oil, electricity, nuclear power, increasingly powerful forms of fire to create new noospheric products. Physical chemistry for fertilizers, for nuclear power, and so forth. So the consumption here is something qualitatively different. This production cycle is a production and consumption of ideas. That these are accumulated over, again, human history. These are not simply, left on somewhere in the past. These powers of discovery are actually accumulated and transmitted through culture. And they're transmitted through the organization of human economy. In a sense, I mean, there's if people heard the term Yankee ingenuity, there is a way in which even somebody growing up using a particular technology, for example, or you imagine what it takes for someone to be able to operate heavy machinery. Embedded both in that machinery, but more specifically in that person's interface with that, the knowledge that they have to understand to utilize that and to know what it's being utilized for, is a whole cultural history of scientific discovery embedded in that. And for many people, that's just a latent power that has to be realized through process of education and socialization throughout society. And the quicker and the more widespread that's done, the more powerful human society actually becomes to pull that horizon closer to make the next discoveries. So even when we're discussing dams, when we're discussing tunnels, when we're discussing turbines, there is a way in which, a very specific way in which this involves and encapsulates these human products, these human ideas. And that's actually what we're propagating. And that's what we want to accelerate. And in the course of doing that, it's going to be reflected in changes in the landscape, changes in our environment, and ultimately changes wherever we decide to take the biosphere and the noosphere. So, and I will say this is something which probably reached its highest level of development under Franklin Roosevelt's administration in the United States. Let me read one more quote. I think that gets at it. Now this is from David Lilienthal, who was one of the administrators of the TVA, the Tennessee Valley Authority project, which was, you could say it's a precursor to NWAPA, in the sense that it was taking an entire drainage basin, an entire river basin, and developing it as one process, as an integrated process, under the total economic mobilization of Roosevelt. And this is how David Lilienthal described the effect. He says, "There is a grand cycle in nature. The lines of those majestic swinging arcs are nowhere more clearly seen than by following the course of electric power in the Tennessee Valley. Rather, in the Tennessee Valley's way of life. Water falls upon a mountain slope 6,000 feet above the level of the river's mouth. It percolates through the roots and the subsurface channels, flows in 1,000 tiny veins until it comes together in one stream, then in another, and at last reaches a TVA lake where it is stored behind a dam. Down a huge steel tube it falls, turning a water wheel. Here the water's energy is transformed into electricity, and then, moving onward toward the sea, it continues on its course, through 10 such lakes, over 10 such water wheels. Each time, electric energy is created. That electricity, carried perhaps 200 miles in a flash of time, heats to incredible temperatures a furnace that transforms inert phosphate ore into a chemical of great possibilities. That phosphatic chemical, put upon his land by a farmer, stirs new life in the land, induces the growth of pastures that capture the inexhaustible power of the sun. Those pastures, born of the energy of phosphate and electricity, feed the energies of animals and men. Hold the soil, that is, they feed the energies of animals and men. Hold the soil, free the streams of silt, store up water in the soil. Slowly, the water returns into the great man-made reservoirs from which more electricity is generated as more water from the restored land flows on its endless course. Such a cycle is restorative, not exhausting. It gives life as it sustains life. The principle of unity has been obeyed. The circle has been closed. The yield is not the sad old tale of spoliation and poverty, but that of nature and science and man in the bounty of harmony. Now, I should note that apparently Roosevelt signed on his voter registration card, or his voter card, I guess, when he went in to vote, his occupation, tree farmer. So I think that's the view, that kind of sense of the integration of mankind's purpose with the purpose of all of nature. That is something that we achieved once at a certain level, and it's been buried. And that is what we're going to reclaim with Nawapa. So